So in part 2, let's draw some conclusions. On the handout is actually a table that I copied directly from the textbook that talks about a summary of the different types of transformations or shifting that we've done. So I'm going to write what I call a generic function. So my generic function has an a, it has a plus or minus h and a plus or minus k. And again, f of x is the function itself. So this could be the x squared, x cubed, the absolute value of x, well, over x could be any one of those. Okay, so what we're going to talk about is what happens if the change is inside versus outside. So I'm summarizing that table a little bit more concisely than everything that they have. So when we look at this, the changes that are on the inside are this plus or minus h. The changes that are on the outside are the a, and then the plus or minus k. Now, your book also does a change on the x that's on the inside, which changes things in the horizontal direction as a compression and stretching. Our course does not include that. We saved that for the 124, the pre-calculus course. So for now, we've only got changes on the inside and changes on the outside of this type. Well, if it changes on the inside, then it is a horizontal change. So this is a horizontal change. And that means it's in the x direction. So, where it's changing the x values. If the change is on the outside, then it's a vertical change, which is a change in the y direction. So inside x, outside y, inside x, outside y. What we notice is that when we were changing on the outside, if it was a plus k, it went up. If it was a minus k, it went down. If it's a that is greater than 1, then it does a vertical stretch. If it's an a less than 1 absolute value, right, ignoring the sign, it does a vertical compression. So those changes in the y direction do exactly what they say. So do what change says. So again, positive k moves it up, minus k moves it down. If the absolute value of a is greater than 0, greater than 1, it's a stretch. If the absolute value of a is less than 1, then it's a compression or a shrink. You can also have a negative on that a. So if you have a negative a, it's a reflection. And those are all the things that we can do in terms of the vertical change. Over here with the horizontal change, what we noticed is that when it said plus h, it went to the left. When it said minus h, it went to the right. So plus h is left. A minus h is to the right. So, and that seems a little backwards to us, but we did do that when we did the circles. If you remember when we graphed the circles, we pulled the information out of the parentheses, out of the function, we did the opposite. So here it's still the same exact thing. So I'm going to write a little note myself is do the opposite operation. So instead of adding, we'll subtract. Instead of subtracting, we would add. The other thing that can actually happen on the inside is you can have a negative on your x. That negative on the x would be a reflection. And in this case, it's a reflection. You're changing the sign on x's, so it's over the y-axis. Back over here, this reflection would be over the x-axis. And that's a beautiful summary. So what I simply remember in a nutshell is inside x, outside y. If it's inside, you do the opposite of what it says. If it's outside, you do exactly what it says. So that's our summary. Now let's go do some more problems. So what we're going to do first is in words, describe the change. So not actually graphing it, but using words instead. So this is example 2. Example 2 states, for each of the following, describe in words how the graph has changed from an original graph of, and our original graph is g of x is equal to the cube root of x. So again, that's that S shape turned sideways. Part A is giving us as a function h of x. This is a new function. It's been transformed. It's 1 plus the cubed root of x minus 2. So I'm going to notice that this plus 1 is outside. This minus 2 is inside. If it's outside, it does what it says to do because it's 1 plus. We're adding 1 to it. So that's going to tell me that we're going to shift the entire graph up 1. So I pick it up and move it up 1. This 2 on the inside, because it's on the inside, we do the opposite operation. So instead of subtracting 2, we're going to add 2. So that moves it to the right. And then we're going to go right 2 units. So up 1 unit, right 2. Part B says f of x, capital F of x, is equal to 2 times the cubed root of a negative x. So we have 2 things going on again. This 2 is outside because it's outside of the radical notation, so it's outside the function. That negative is inside because it's inside the radical. If it's outside, it does what it says. And this time it's 2 times. So that means we're going to take each y value and multiply them by 2, which is going to give me a vertical stretch. A vertical stretch by 2. Okay, the negative on the inside, well, negatives attached to x's or negatives that are multiplied are reflections. So in this case, we're going to reflect. And what we're going to do is change this line on the x's. So positive x's become negative x's become positive x's. So that's a reflection across the y-axis. So we're going to reflect across. You can say over the y-axis. Okay. And then finally, part C, we have r of x is equal to a negative cubed root of x. So this negative is outside, and it's the only thing that's happening this time. We know that anything that is outside changes things in the y direction. So positive y's would become negative y's would become positive y's. So that's a reflection over. And if I'm going this way, it's over the x-axis. You really have to stop and think. Mentally picture what's going on. We'll use these transformations throughout the rest of the course. So we'll do it with every function that we introduce from here on out. So it's important to get a good basis here.